Welcome back, everyone, to the ADSA here in Ottawa, Canada. Joining me today as co-host for this session is Dr. Clay Zimmerman. Welcome, Clay. And our guest is Dr. Mike Van Amburgh and Andres Ortega from Cornell University. Mike, Andrea gave us an oral presentation earlier today. Would you mind just telling us a little bit about him?
Oh, sure. So Andrea, he's a fun guy. He came to Cornell to be a veterinarian, born and raised in Miami.
Wow.
No, not a lot of cows.
Not Miami, Ohio.
Yeah, not Ohio.
Okay.
No, not Ohio. And anyhow, he came into the lab and started, working and helping us with all sorts of things. And he started asking harder and better questions, to the point where he got really interested in amino acid metabolism and chemistry. And I said, hey, let's give you a project. So he did an honors project on amino acid recoveries that has partially been published, but he's extended that a lot. And then he decided not to go to vet school, and I said, well, I'll upgrade my system for amino acids if he'll stay for a PhD. So here we are.
Nice. Nice. Excellent.
Very nice.
Andreas, you gave a presentation today called Abomasal infusions of essential and non-essential amino acids to evaluate energy and amino acid utilization, productive efficiencies, and metabolism in lactating dairy cows. Now, Mike, in marketing, we try to communicate in small sound bites. Evidently, you guys don't operate under that same paradigm in the scientific community. How in the world did you come up with that? Sorry about that.
You almost didn't get it out there. I was worried about you there,
I was a little worried as well.
No, it is pretty long.
It is. Andreas, tell us a little bit about your presentation today.
Yeah, so this was a study we ran last year, which was actually pretty interesting. It was very intensive because it was Abomasal infusions, right? So we had the cannulated cows and we were infusing directly into the Abomasal. And so we have been thinking a lot about MP, metabolized whole protein, which is both essential and non-essential amino acids. And I started reading a lot of Dr. Wu down in Texas A&M, and he doesn't work with ruminants now, but he's very focused on non-essential amino acids and all these functions that non-essential amino acids play within the body. So I got really interested in finding out more about that in lactating dairy cows. So with Mike, we came up with this study where we would try to see what will be the effects if we were starting to vary both the essential, non-essential amino acids, and make sure of both of them. So in this study, we infused only essential, only non-essential, and a mix of essential and non-essential amino acids. But then we took that a step further, and we infused essential amino acids and twice the amount of non-essential amino acids. And the idea behind that was that we know the essential amino acid requirement, but we know that some of that requirement is used for the production of non-essential amino acids. So if we're able to provide that, and these essential amino acids do not have to then produce the non-essential amino acids, then we should see an efficiency of use change there, some of those amino acids being used for other substrates, and hopefully we would get a production efficiency there. We unfortunately did not see the production results that we wanted because, as we know, we work in a dairy cow farm. So we ran out of the conventional corn silage that we were feeding, and we had to switch to a BMR, which, of course, that increased our digestibility, increased our MP supply. So the diet that was supposed to be deficient in protein really wasn't as deficient as we would have wanted it. But although we didn't see the productive results that we wanted, we did see some really interesting metabolic results in which that treatment that had the higher amount of non-essential amino acids, it showed a significant increase in the amount of insulin, which is telling us that all of these amino acids were probably being used for these other purposes, producing other metabolites that then increase the amount of insulin.
So what stage of lactation were the cows?
So we started right after peak, so around 60, 70 days in milk, and then we ended up, the last few cows that ended were probably at 180, 190 days in milk, so mid-lactation cows.
And how did you come up with the the cocktail for the essential amino acids
Yeah,
and
that was
non-essential amino acids.
that was the other problem that we had, right? Most of the Abomasal infusions that have been done with amino acids, they've always taken casein, milk protein, right, as the basis for how much they were going to infuse. But we know that any amino acid or protein that we feed the cow, it's going to go through a bunch of all these other processes, and whatever ends up in the milk is not exactly what we're feeding the cow. So we wanted to actually represent MP, the metabolizable protein, and break that down into the individual essential and non-essential amino acids. So we formulated 2 diets, one that met all of the MP requirements, one that didn't, and based on the difference of MP there, then we knew how much we were going to infuse. And the essential amino acids, that was really easy because the CNCPS is able to tell us the individual essential amino acids, but the non-essential amino acids, we had to use some data from our lab where we did multiple time hydrolysis on feeds and microbes in order to come up with a profile for the non-essential amino acid portion of that.
So when you infuse a higher level of non-essential amino acids, you reduce the level of preformed fatty acids in the milk, right?
Right, yeah. Well, that was the other really interesting part. So associated with the whole insulin response, right? We know that insulin, it's a potent lipolysis. It lowers the amount of lipolysis, so there was a lower amount of fat that was being broken down. And as we know, preformed fatty acids either comes from endogenous fat or from the diet. And since all these cows were being fed the same diet, that decrease in the preformed fatty acids was probably coming from that decrease in lipolysis being caused by probably insulin or any other metabolite that was being produced from the non-essential amino acids.
So what would be some takeaways from this work, and what are the next steps?
Yeah, so I think one of the main takeaways from here is that we haven't really explored non-essential amino acids. That hasn't really been done, and I think we showed some really important interactions here between amino acids, all of them, essential and non-essential, and also fatty acids and other metabolic responses. So I think we should start to look into these non-essential amino acids, maybe start to incorporate some of these into nutritional models to see if we can better predict the amount of MP that these cows are seeing. That's one of my takeaways. Mike, I don't know if you have another one.
Yeah, well, I think, we just came from another talk where they infused some other non-essential amino acids and saw pretty big responses, right? They did it with just one amino acid, and they started prior to calving and into 21 days of lactation. So I think we a couple things there, Clay. Where should we go? One of the positives and the negatives of his study is that we had cows, early on running 52 kilos of milk, right, at 4.5 fat. So we had these crazy high-performing cows, which we thought should help us kind of pull them apart, but it didn't happen that way, probably because the diet, that corn silage, made enough more microbes that we were just insensitive to some of our treatments. But I think framing it out in the model, and then the other part is probably starting in a phase where we know there's some true metabolic deficiencies.
Right.
Right. And maybe in established lactation, that's harder to do. Mm-hmm. So we probably have to back up and get in those, that prepartum period through the, 21 to 42 days of lactation.
So
that's where I'd go.
So the period, they were 18-day periods,
18-day periods, right?
So how'd you determine the length of period?
Well, we wanted to give enough time for the new treatment because the cows were going to receive this treatment, right? So we wanted enough time between treatments where we wouldn't have that carryover effect from one treatment to the next. And it seemed from the literature that most of the papers, if you provide that adaptation period for up to like 14 days, which is really the adaptation period, that was enough to prevent any carryover from the last treatment. So it was 18-day periods. The first 14 days were adaptation, and then 15 through 18 we got the samples.
Okay, thanks.
But that question, one of the things that we're still struggling with, right? There's no study that's perfect, right? and it's because each cow had a unique sequence.
Right.
Right. So I'm trying to figure out, can we map this out in a slightly different way and see if we can find something, because I'm still not sure that we've, it doesn't look like we have carryover effect. We've tested for that, but there may be some other aspects to it that we just haven't figured out how to pull the data
Right.
apart yet.
Right.
Andreas, where are you in your PhD journey?
I am almost done. I have a couple more months here. I'm just wrapping up a project in the lab with amino acids, of course, and I hope that probably by September I'll be defending my dissertation, and then I'll move on to my next step. Not sure what it is yet.
No?
No.
Gonna go back into academia, maybe start off with a postdoc?
Yeah, I think my plan right now is to start with a postdoc. I love doing research. I love what we do, so I think I want to keep exploring some more research, doing some different things. As Mike mentioned, I've been working with him for almost 8-9 years, so, and I'm really appreciative of everything that he's taught me, right? But I think I need to see other types of research and what else we can do.
Yeah. Well, you're a bright young man. You've got a great mentor. I'm sure the future is very bright for you, and I want to thank you for joining us this afternoon.
Thank you very
Appreciate
much.
it. Thank you, Andreas.
Yeah,
Thank you, Mike.
thank you.
So thank you.